I welcome you all of my dear friends. Today I have brought the video on determinants. This determinant chapter is there in 12th standard, and all of our 12th standard students, they are already preparing for their board examinations. That's the reason I thought that let me prepare some academic video on mathematics. I am going to solve two questions on this determinant, and we will see that what are the basic principles we are following in solving the questions related to determinant. So we will calculate the value of determinant. I have brought two questions here. Of course, these two questions are available in CBSE book in miscellaneous exercise. Right, so miscellaneous exercises on chapter 4 and page number it is 99. Okay, so I can say that this particular questions, these two questions are available on miscellaneous exercise. Exercise on chapter 4, page number 99. Okay. Yes, so let us solve these two questions. We all know determinant, matrices and determinant. So first we learned about matrices, and even many questions you can have a glance on the video which I have already prepared for matrices, and even on determinants also my videos are available. Kindly have a glance, and these two questions let us solve it. Okay, so the question given, question number 1, it is given that prove that the determinant so and so x sine theta cos theta, the elements are minus sine theta minus x 1 cos theta 1 and x, is independent of theta. It means when we will be solving, we will be evaluating this determinant, whatever the last expression we will get, that will not have any kind of sine theta or cos theta in it. It means that theta will not be there. That is the question. So let's see, let us evaluate. Solution for question number 1. So if we have taken this determinant x sine theta cos theta minus sine theta, then minus x 1 cos theta 1 and x. Now we know that how to evaluate. So if we will take this particular row, so we know that the sign will be plus, minus, plus. Okay, similarly the sign will come plus, minus, plus, like this it will be there. Okay, then minus, plus, minus and plus, minus, plus. So this used to be the sign. Okay, this used to be the sign. So by utilizing those signs we will be evaluating. Okay, so let me erase those signs. Okay, this is not required, so you all know, that's why I placed it. Okay, so let us erase it, or sorry, let us evaluate it. So with first element x, so we know that we will be going for multiplication of this minus x here and this one. So minus x into x, it will give minus x square. Then this one and this one, in between minus will be there, and 1 square, 1 into 1 is 1, so this will be minus 1. Now next one, minus sine theta, this one. With this we are going to evaluate. So now this element we will take and this element we will take. So it will become what? Minus x sine theta. Okay, and this cos theta and 1. So minus cos theta. Okay, plus. Now we'll take this one, cos theta. So here cos theta, and we'll take this one, minus sine theta into 1. So this will become minus sine theta, and these both are minus, negative, minus x, and cos theta is not negative. So minus x cos theta, so that in between if minus will be placed, so it will become plus x cos theta, plus x cos theta. And further we can solve it as x into minus x square, so minus x to the power cube, and x into minus 1 is minus x. Okay, right, minus into minus plus x sine square theta, and minus into minus, that is also plus, and this will be giving us sine theta cos theta, sine theta cos theta. Then here cos theta into minus sine theta, that will become minus sine theta cos theta, and it will become plus x cos square theta. Now you see this sine theta cos theta will get cancelled with this minus sine theta cos theta, and we will be having here as minus x cube minus x plus x we can take common, and it will become sine square theta plus cos square theta. So this will be giving to us as minus x cube minus x, and sine theta plus cos, sine square theta plus cos square theta, we already know that that is equal to 1. So x into 1, so it will become plus x, and this x and minus x will get cancelled, and we will be left with the answer as minus x cube. So this is the solution. Now we can see the expression what we got at the end. It is completely independent of theta. So what question number 1 is asking, prove that the determinant is independent of theta, and after evaluation we found that determinant is independent, that evaluation result, end result is independent of theta. Right? By using similar principle, we will solve question number 2. Right. Let me erase it, and we will be going for question number 2. So it is simple only, and with practice it can be solved at a faster rate. Right, it can be solved at a faster rate by practice. So it's not so difficult, and we can evaluate the determinant by using row also, or by using even column also. So it's not necessary that always we will be using or evaluating the determinant by using row only. Even we can evaluate by using column also. Okay, generally we take that first row and we used to evaluate. That's the reason we are evaluating. Okay, now we will be solving question number 2. We will evaluate question number 2. So now this is the determinant. So we will take as cos alpha cos beta in bracket, then again cos beta into cos alpha. So cos alpha cos beta, and minus 0 into sin alpha sin beta. So it will be 0 only. Okay. Then minus cos alpha sin beta. I am evaluating the determinant by using row 1. Okay. So minus cos alpha sin beta will give minus sin beta cos alpha. So minus cos alpha sin beta, minus cos alpha sin beta, and then minus sin alpha cos beta into 0. So it is minus 0. Okay. Then further minus sin alpha. Okay, so that will be minus sin alpha, and in bracket minus sin beta and sin alpha sin beta. So it will be minus sin alpha sin square beta. Okay, and then again minus cos beta is there. So sin alpha cos square beta. Cos square beta. Okay, right. Then further, so this evaluation here we can write it as like this. Okay, cos alpha cos beta and cos alpha cos beta. So it will become cos square alpha cos square beta. Okay, then minus cos alpha sin beta, and here minus cos alpha sin beta. So minus and minus, it will become plus. So cos square alpha and sin square beta. Okay, then further minus sin alpha, and here minus sin alpha sin square beta is there. So minus minus will become plus, and sin square alpha it will become sin square beta is there, and then minus and minus again it will become plus. Here also sin square alpha and cos square beta. Further, now in these two expressions we can take cos square alpha as common. So it will become cos square beta plus sin square beta, and from this expression these two, sin square alpha we can take common. So sin square alpha, so sin square beta in bracket plus cos square beta. By using the expression, that is sin square theta plus cos square theta is equal to 1. This particular expression or formula we are going to utilize it. So this will become as 1, this one also will become 1, and it will be giving us as cos square alpha plus sin square alpha. Further, this one also will become cos square alpha plus sin square alpha is equal to 1. So in this way, so you have seen that how fast we can calculate. It's not necessary that we should go for each and every step. Even 1 or 2 step we can calculate directly. I have solved in front of you so that you can understand it in a proper manner. So like this we have to solve the questions of determinant. I am expecting that all my students have understood how determinant has to be solved. What should be the approach in evaluating the determinant. So if you have liked the video, then kindly subscribe and share with your friends. If you have not subscribed the video till now to my channel, please subscribe it at the earliest. Thank you very much.